You know, from the quietest whisper a microphone picks up to the absolute roar of a concert speaker, there's this hidden force at work. It's in your phone, it's in your Wi-Fi router, your car stereo, everywhere. So today we're going to pull back the curtain on one of the most fundamental, unsung heroes of modern electronics, the amplifier.
So, here's the plan. First, we'll get right down to the core idea of what an amplifier actually is. Then, we're going to take a little trip back in time, from the old-school vacuum tubes to modern transistors. We'll also uncover the ridiculously clever trick that makes them so precise, check out the different types, and finally, see where these things are hiding in plain sight all around us.
All right, let's just dive right in. At its heart, what is an amplifier really doing? I mean, it seems a little like magic, but the principle is actually beautifully simple.
Okay, here's the absolute key. An amplifier doesn't just create energy out of thin air. No way. It takes a tiny, weak signal, the input, and uses power from a battery or an outlet to build a much stronger but otherwise identical signal at its output. So think of it less like a magician and more like a really skilled sculptor who uses raw power as clay to shape a bigger, perfect copy of the original.
And this visual, it says it all. That little blue wave, that's your input. Maybe it's the faint signal from a guitar pickup. The amplifier's one and only job is to create that big red wave, a faithful, proportional replica that's strong enough to actually drive a speaker. Notice the shape is exactly the same, right? Only the size has changed. That's the goal.
So, if you boil it all down to one single rule, it's this. The defining property of any amplifier is that its power gain has to be greater than 1. Simple as that. If it's not making the signal more powerful, well, then it's not an amplifier.
Now that core idea is timeless, but the technology that makes it happen? Oh, it has gone through a massive revolution. I mean, it's taken us from these big glowing glass bulbs to microscopic components that literally power our world today.
Our whole story really kicks off back in 1906 with the invention of the vacuum tube. That was the spark. But the real game changer, that came in 1947 at Bell Labs with the very first transistor. And then the final leap was in 1959 with the invention of the MOSFET. That's a type of transistor that was so small and easy to make, it's the reason we can now pack billions with a B of tiny amplifiers onto a single computer chip.
And what's wild is that for half a century, these vacuum tubes were the only game in town. I mean, they were the engines behind that first electronic age, making things we totally take for granted, like just hearing a radio broadcast or making a long-distance phone call, a reality for the first time ever.
This slide just captures that transition perfectly. We went from these bulky, fragile, power-hungry vacuum tubes to tiny, super reliable and efficient transistors. And look, this wasn't just an upgrade. It was a complete paradigm shift. It's what unlocked the entire world of portable electronics, from the very first transistor radios all the way to the smartphone sitting in your pocket right now.
But you know, making a signal bigger is really only half the battle. Making a perfect copy? That's the real challenge. And this brings us to this brilliant engineering principle that makes things like high-fidelity audio even possible.
So that's the big question, right? If the electronic parts themselves aren't perfect, how in the world do you build a nearly perfect amplifier? How do you get rid of all that noise and hum and distortion that the amplification process can create on its own? And the problem was a big one. Those early amplifiers were far from perfect. They introduced distortion levels around 5%. Now that might not sound like a lot, but trust me, to your ears, it's the difference between a muddy, noisy recording and one that's crystal clear.
The solution, figured out by an engineer named Harold Black back in 1934, is just pure genius. It's called negative feedback. Basically, the amplifier checks its own work. It takes a tiny sample of its own output, electronically flips it upside down, and then mixes it back in with the original input. Any error or distortion the amplifier accidentally created is now out of phase with itself, and it just gets canceled out. It's brilliant.
And just look at the results. This self-correcting trick is just astonishingly effective. Negative feedback can take distortion from a very noticeable 5% all the way down to an almost immeasurable 0.001%. This right here, this is the secret sauce behind the clean, precise sound of all modern audio gear.
Okay, so now we know how they work and how they get so darn perfect. It's time to meet the family. See, the word amplifier is a pretty broad term, and it covers a whole range of devices built for very different jobs.
So on a really technical level, engineers think about 4 basic flavors of amplifier. They're all categorized by their input and their output. So for instance, some are built to turn a small voltage into a bigger voltage. Others might turn a tiny current into a big voltage. You can think of these as the fundamental Lego bricks that engineers use to design much more complex circuits.
But out in the real world, you're most likely to run into these too. You've got power amplifiers. These are the workhorses. They're the last thing in your stereo, providing the raw muscle you need to physically move the cones in your loudspeakers. And then you have operational amplifiers, or op-amps. These are these tiny, incredibly versatile brains on a chip. They are like electronic Swiss Army knives that you can configure to do almost anything, from filtering signals to actually performing math.
So for our last section, let's bring it all home. We've talked theory, we've talked history, but where does this technology actually impact your life? Well, the answer is pretty much everywhere.
Seriously, every single time you connect to Wi-Fi, your router is using amplifiers to boost that signal. The bright, vibrant colors on your TV, handled by video amplifiers. Your phone uses them to send and receive calls. From the servo motors in giant industrial robots to the electric guitar on a stage, amplifiers are the invisible, absolutely indispensable heart of our entire electronic world.
And that just leaves us with a final thought. This core technology, first thought of over a century ago, is still absolutely essential. So as all of our devices get smaller and faster and way more efficient, the ongoing challenge is to keep reinventing this fundamental component. What's the next generation of amplification going to enable? That's a question engineers are trying to answer right now.